Today we're looking at Chapter 5, Test Review for Geometry. Excuse my voice. I'm going to try and talk as loud and clear as I can. Here, you're asked to find an angle bisector, so you're going to look at all three angles here. Angle G, angle H, and angle I. And you can see that one of them is split into two congruent parts. So that's going to be your angle bisector, which is HJ. And that's the bisector that's cutting angle H into two equal parts. The next one, you're given the total perimeter of this figure, and with that you're supposed to find the value of x. So basically you add all the sides together and put it equal to 34. And then look at the figure itself and tell me the relationship between RS and PQ. Since they are perpendicular, you're going to say that they are perpendicular. For this one, you're told that point N is the centroid. So that means it's cutting it into 2/3 part and 1/3 part. So the smaller part is 1/3 of the total segment and the larger part is 2/3. So we're finding JN. It gives us KN is 4. So that's the smaller part. So to find 2/3 of it, we're going to multiply it by 2 to get that JN is 8. Here we're given the vertices of triangle ABC. We're asked to find the centroid. This would be best to use a piece of graph paper. I'm going to try and show you as best I can here. So we have -1, 11. A. B is 3, 1. And C is 7, 6. So we have a triangle here. Now on graph paper this would look a little bit easier to do, but you're looking for a place where you can draw from the vertices to the other side either a horizontal line or a vertical line. In this case I would either do B to AC or C to AB. I think I'm going to just do B to AC in this case. That's going to be my line, and I'm going to find the midpoint where it crosses AC, and that's going to be the midpoint formula of AC. So the midpoint formula, if I'm using that, I have the x's of A and C over 2 added together, and the y's of A and C over 2 added together. So I get -1 plus 7, which is 6 over 2. That's 3. And 11 plus 6 is 17 over 2. That's going to be 8.5. That's my midpoint. 3, 8.5. So my distance of my line here, I'm going to count. It starts at 1. I go from 1 to 8.5. That's 7.5 units. So I'm going to multiply this total by 2/3. So 7.5 times 2/3. Which gives me 30 over 6, or 5. and I'm going to count up from B 5 units. That's going to be my point. So if I count up from 1, 5 units, that goes up to 6. So that's 6 on the y-axis, and 3 was already on the x-axis if I'm using the line from B to the midpoint. So my centroid is going to be 3, 6. Right here. Next one, it says PO is an angle bisector. That means it cuts it in half. So all we're going to do is put, if we're finding x, 2x minus 15 equals x plus 10. Excuse me. And solve for x. So we get 2x equals x plus 25. Subtract the x, so x is 25. Next one, we're writing an inequality that relates x and z. Really just relates the two sides. So we're looking at the angles across. 150 is an exterior, so that makes this interior 30, which is across from x minus 5. 57 is across from this side, but we don't need that. So if we find the third angle, 30 plus 57 is 87. We're going to take 180 minus 87. We're going to get 93. This is 93. So we're going to say that 7z is greater than x minus 5, based on the fact that it's across from the greater angle. Here we're just listing the angles in order from smallest to largest. So we're going to look at each side, and the smallest side is 1.8 across from angle T. Then you have 3.9 across from angle V, and 5 across from angle U. That's all you do. This is the same kind of situation except for we're listing the sides. So 41, the smallest angle, goes to FH. 57 goes to GH, and 82 goes to FG. Here we have the name the longest segment, so we're just looking for the biggest angle, 96, and that's across from LN. So LN is our longest. Here we're writing the assumption you would make to start an indirect proof. It's always going to take the then part or the conclusion and negate it. So we're going to say instead of n squared is an even number, we're going to say it is not an even number. Same thing here, write the assumption you would make to start the indirect proof. If AD is an angle bisector of equilateral triangle ABC, then AD is an altitude, so we're going to say then AD is not an altitude. Here we're seeing the assumption again. So we're looking at the proof part. It says SV is not perpendicular to PQ, so the assumption would have to be SV is perpendicular to PQ. Here we have the measures of two sides of a triangle. If we're trying to find the range of values here, we have x in the middle. We're going to add them together to get the highest, so it has to be less than that. We're going to subtract them to get the lowest, so it has to be greater than that. So 14 plus 29 gives us 43, and 29 minus 14 gives us 15. There's our range. Here the BD is a median. That's going to make it a perpendicular to the side of triangle ABE. So right here BD. So if AD is 8, it also puts it in cuts it in half, or 2 equal parts, sorry. So we're going to make DE also 8. This one says YW bisects the angle that makes the two sides here equal. So to solve for x, I'm going to put them equal to each other. Solve for x. So x equals 35. Next one, write an inequality relating BC and ED. BC is going to be across from the smaller angle, so BC is less than ED. This is angles relating. So angle 1 is across from the smaller side, so angle 1 is less than angle 2. Here we're filling in the proof. So here's the start of the proof. You're given that EH is equal to GF, and EG is greater than HF. We're seeing if angle EHG is greater than HGF. So we're given that EH is equal to GF. Notice the second step, it's just putting EH is congruent to GF. So that's just the definition of congruent segments. Kind of redundant. Then you have GH is congruent to itself, which is always the reflexive property. So with that, why is EHG congruent to HGF? Well, it has to do with either the hinge theorem or the converse of the hinge theorem. In this case, since we're comparing angles, we're going to say that it's the converse of the hinge theorem. So make sure you know the hinge theorem and the converse of the hinge theorem for the test. And that concludes the Chapter 5 test review.